All right, so this is the very last lesson we are going to go over this year in geometry, and if you can believe it, this actually finishes the curriculum. We got through everything we needed to get through. So we're going to talk about chapter 12 all in one. So it's all about solids, volume, surface area, stuff like that. So we'll just get into the solids first. There are polyhedrons. Uh, and not polyhedrons, just like there's polygons and not polygons. So as long as there's something curvy in it, it's not a polyhedron. If there's no curves, it's a polyhedron. So the two types of polyhedron are prism and pyramid. A prism is when you have two shapes that are exactly the same and they're connected by rectangles. The two shapes that are bases that are the same can be rectangles as well, in which case it doesn't matter how we're looking at it. But if it's a shape other than a rectangle, we have to have them across from each other. They are parallel to each other. They are congruent to each other. They are called our bases. In a pyramid, we have a single base, so one single shape, and they're all connected with triangles to a single point called the vertex. Then we have our non-polyhedrons. We have a cylinder. So a cylinder is almost like a prism, except the base is a circle. A cone is almost like a pyramid, except the base is a circle. And then a sphere, like a basketball, soccer, any ball, that is really defined as the set of points in space that are the same distance from a given point. So that point, our center, any point equidistant from it in any direction makes up the sphere. We name polyhedrons or polyhedra by the shape of the base. So if I have two triangles in the picture and the rest are rectangles, that's a triangular prism. If every single face in the picture is a rectangle, it's a rectangular prism. If I have two pentagons, that's a pentagonal prism, right? You understand here? Naming it by whatever shape the base is. If there's a pyramid, again, we're going to name it by the base. If it's all triangles, that's going to make it a triangular pyramid. We're not going to really deal with many of those. We're mostly going to deal with rectangular or square pyramids, and there's also any other polygon can be the base. This is not really super important to know. It's just interesting that we have something called platonic solids because of Plato, right? The old guy Plato. Um, they are regular polyhedrons, which means all the faces are congruent polygons and all the edges are congruent. And these are the 5 kinds there are. The most common we would see is a cube, where every single face is a square, and it's 6 squares altogether. All right. There's also the tetrahedron, octahedron, dodecahedron, and icosahedron. Now we're going to get into actual formulas. We're going to talk about surface area and volume. So surface area is whenever you're covering a shape. It's the area of the outside of the shape. If you're finding the entire surface area, that's the surface area. If you're only finding the rectangle parts of a prism, that's called the lateral area. So lateral area is minus the bases. No bases in a lateral area. Just telling you this, we're not going to really need to know it, but it's important to, see these kind of things. So surface area of a prism is 2 times B plus pH, and this B stands for area of the base. So we have to identify what the base is in order to find the area of it. The P stands for the perimeter of the base, and H is the height. We're going to define the height as the distance between the two bases. Volume is actually much simpler. It's just going to be area of the base times the height. So in our first example, we're going to find the surface area and volume of this triangular prism, right? I have 2 triangles in the front and back here. They are considered my bases. So anytime I have a prism, I'm going to set up B, P, and H because I'm going to need all 3 of those things. B, P, and H. Remember, B is area of base, P is perimeter of base, H is the height. Since I know the 2 bases of the triangles, the distance between them here is 14, so I can already fill that in. So now area of the base. We know area of a triangle from the last chapter that we did is half times the base of the triangle times the height of the triangle. Right? This base and height is different than the base and height of the prism. So we're going to have 1/2 times 11 times 7, or 38.5. For perimeter of the base, I need all 3 sides of this triangle, and they don't tell me this one right now. So I would do Pythagorean theorem because it's a right triangle. I'm going to spare you that work right now, but it would be 7 squared plus 11 squared equals c squared. And if I do that, I get 13.04. You're going to notice I'm going to kind of skip over some math today just because I want to get through the whole chapter without taking up too much of your time. So now the perimeter is going to be the three sides of the triangle added together, 7, 11, and 13.04. And if I add, 11 plus 13.04, I get 31.04. And once you know B, P, and H, it's just about plugging into these two formulas. So S is going to be 2B plus pH. 2 times the B value plus the P value times H. All right, so that's going to be double the 38.5, or 77, plus 31.04 times 14, which is 434.56. So altogether, if I add those two, I get 511.56 meters squared. All right. Surface area is an area, so the units are going to be squared. Volume, we said, is going to be a little simpler. It's just going to be base times height, area base times height. So it's going to be 38.5 times 14. So that is going to be 539. Since volume takes 3 different dimensions into account, we're going to have units that are cubed. All right, and there's our volume. So you're going to go ahead and try this one. Find the surface area and volume of this triangular prism. Pause when you're ready, come back and check your answer. All right, so for try 1, we should have gotten a surface area of 336 square feet and a volume of 288 cubic feet, or feet cubed. Our next shape is the cylinder. So a cylinder has a radius and a height. So the surface area is going to be 2 pi r squared plus 2 pi r h, and the volume is just pi r squared h. So we're going to find the surface area and volume of this figure. This is a somewhat confusing diagram because they have it pointing to one part, but because they drew the whole thing, we're going to assume this is really the diameter. So my radius is going to be half of that, or 10.2. And the height, just like with a prism, the distance between the bases, the distance between the circles, is 22. So that's my h. So now we're going to plug it into the formula. Surface area is 2 pi times the radius squared, so in this case 10.2 squared, plus 2 pi radius height, so 10.2 times 22. So we're going to do this part first, and I'm not going to multiply by pi. I'm going to keep pi till the very, very end, just in case they ask for an exact answer. Just so you know, if they want an exact answer, that means pi should still be in the answer. You should not have multiplied by its equivalent. So 10.2 squared times 2 is going to be 208.08 pi. Plus, I'm going to do 2 times 10.2 times 22, leave the pi, so that's 448.8 pi. We can treat the pi almost like a variable right now, so I'm going to only add the coefficient numbers. So we get 656.88 pi. And this would be the exact answer. Now I'm okay with multiplying it by the pi button. I'm always going to use pi button. And I get 2063.65 square centimeters. All right, again, volume is going to be a little simpler, pi r squared h. So that's pi times 10.2 squared times 22. So I'm going to make sure I square my 10.2 first, then multiply it by 22. Doing that, I get 2288.88, and I still have pi there. So when I multiply by the pi button, I get a volume of 7,190.73 centimeters cubed. All right, you're going to go ahead and try the next one. Pause when you're ready, come back and see your answer. All right, so try 2 should have had a surface area of about 361.91 square centimeters and a volume of about 407.15 cubic centimeters. The radius in this case was 6. The whole diameter was 12, so the radius was 6. As for our next shape, we have the pyramid. Pyramid is where it starts to get a little complicated because now there's 2 different kinds of heights. So if I look at the bottom pyramid here, I have a height going from the vertex to the center of the base. That is the regular height. Whenever you measure something, you measure it at a right angle, straight up and down. But if you imagine this was actually a mountain and you're climbing up the side of the mountain, that's a slant height. So the slant height is the height along the edge. And I don't know why they drew it in front here. Normally we see it more along the side like this. They might draw the right angle there, but it's not a right angle with the base, it's a right angle with the edge. So what it really does, if I were to draw the slant height in this one, it makes a right triangle. So we have the height, we have the slant height, and then we have half of the length of the base, right? Half of the length of one of the sides of the base. So surface area is going to be the area of the base plus half times the perimeter of the base times the slant height. L is slant height. I don't know why they're not calling it S, maybe because S stands for side length. So L is going to be our slant height. Right? It's the second letter in slant. We'll take it. Volume is either 1/3 times area of the base times the height, or area of the base times the height over 3. So if we look at our first example, I know I'm going to need 4 things. I'm going to need area of the base, I'm going to need perimeter of the base, I'm going to need the real height, and I'm going to need the slant height. So the measurement that they give me is center to top, so that is the regular height. So I'm going to put 15 here. The area of the base, this is a square, every side is 11, so 11 times 11 is 121. All 4 sides of the base are 11, so I'm going to do 4 times 11, and I get 44 for the perimeter. We said the regular height was 15, and now I want the slant height. So if I were to draw this out, and there's my slant height, my regular height was here, that was 15, and this piece is kind of like right here. So we're looking at half of the whole length of 11. So we're going to put 5.5 there. And I'm just going to use Pythagorean theorem to find my L. Again, this is the part I'm going to kind of skip. So L squared equals 15 squared plus 5.5 squared. We get L is about 15.98. So now I can find surface area and volume. So S equals the area of the base plus 1/2 times the perimeter of the base times the slant height. All right, we're not going to use the 15, we're using the 15.98. And guys, your slant height should always be more than your regular height because it's the hypotenuse of a right triangle, which means it has to be the biggest side of that triangle. So I'm going to do the 1/2 times 44 times 15.98, and I get 351.56. And if I add to that the 121, we get a surface area of 472.56, and that's inches squared. All right, volume, I'm going to do area base times height over 3. So that's area base is 121 times the real height, the regular height, is 15 over 3. So this comes out to be 605 inches cubed. All right, you try the next one, pause, when you're ready, come back and check your answer. All right, for this one, if you made your little right triangle, we're looking for the slant height. We knew the regular height was 6. Half of that 3 was 1.5, so we got a slant height of 6.18. So then the surface area was 46.08 square centimeters. The volume was 18 cubic centimeters. All right, the next shape is the cone. A cone, much like the pyramid, has a slant height and a regular height. Same idea. The only thing is, we're going to just use the radius as the third part of that triangle. We don't have to worry about cutting a side in half unless they happen to give us the whole diameter. So surface area is going to be pi r squared plus pi rl. Volume is going to be pi r squared h, all divided by 3, right? Or 1/3 times pi r squared h. So in example 4, they're giving us the whole diameter is 7. So the radius is 3.5. We're also going to need h and l. So I'm looking at this 4. The 4 is inside the figure, so that's the regular height, which means I'm going to have to find the slant height. Oops, won't pretend that's an L. So over here is going to be our 4. Down here is going to be the 3.5, and we're going to do Pythagorean theorem. So that's going to be L squared equals 4 squared plus 3.5 squared. We get L is about 5.32. So surface area is pi times the radius squared, so it's pi times 3.5 squared, plus pi times the radius times the slant height. I can tell you the biggest mistake people make between the pyramids and the cones is they use the wrong kind of height when they go to plug it in. All right, so just like the cylinder, I'm going to keep pi until the end. So this is going to be 12.25 pi. This is going to be 18.62 pi. Together, this is 30.87 pi. So that's our exact answer. And then our approximate answer is 96.98 inches squared. All right, our volume is pi r squared times the real height, regular height, all over 3. So I'm going to do 3.5 squared, multiply that by 4, we get 49 pi over 3. That's probably as exact as we're going to get, because otherwise it's a repeating decimal. So now when I get my approximate answer, it's about 51.31 inches cubed. All right, you're going to go ahead and try the next one. Pause. When you're ready, come back and check your answer. All right, for this one, we have the slant height this time. We had to find the regular height. So Pythagorean theorem, 11 squared equals h squared plus 4 squared. We get about 10.25 for the height. So then surface area is about 188.5 inches squared. Volume is about 171.74 inches cubed. We're so close to being done, guys. Sphere. I didn't draw a sphere here, but a sphere only has a radius. So the surface area is 4 times pi r squared, and the volume is 4 times pi r cubed all over 3. So in example 5, my radius is 18. So for my surface area, we're going to have 4 pi 18 squared. So I'm going to make sure I square the 18 first, then multiply by 4. So an exact answer would be 1,296 pi. And the approximate answer would be 4,071.50 centimeters squared. All right, volume, we have 4 pi times 18 cubed. All right, that's the part people mess up on here. They still do squared instead of cubed. So we're doing 18 to the third power, multiplying it by 4, dividing by 3. We get 7776 pi. This is going to be a pretty big number. Our volume is 24,429.02 cubic centimeters. All right. So you go ahead, try the next one. Pause when you're ready. Come back, check your answer. All right, for this try, the radius was 6.5. The surface area was 530.93 square meters. The volume was 1,150.35 cubic meters. We didn't get to talk a lot about intersecting solids, but you can intersect a plane with a solid, so like basically a piece of paper through a solid. If you have the plane intersect through the largest part of the circle, it's called the great circle, it actually creates two congruent halves or hemispheres. So if you imagine you had something round and you cut it in half, you'd have two hemispheres, two halves of that sphere. So we could also find the surface area and volume of a hemisphere. And normally I would go through the whole process of how we came about these formulas, but for now we're just going to say surface area of a hemisphere is 3 pi r squared, and volume of a hemisphere is 2 pi r cubed all over 3. Right, if you want to know how we came up with them, send me an email and I will go over that with you. So for example 6, my radius is 2.8. So my surface area is going to be 3 pi r squared, so 3 pi 2.8 squared. So that's going to be 23.52 pi. And then the volume is 2, oh, sorry, didn't finish that one. That's the exact answer. The approximate answer would be 73.89. All right, volume is 2 pi r cubed, so that's 2.8 to the third power, all over 3. All right, so this, it's not even exact because of all the decimals. I'm going to say 14.63 pi is still approximate because I rounded that. I think it was 14.6346 repeating or something like that. So now when I convert that times the pi, it's 45.98 centimeters cubed. All right, so you're going to try this one. Pause. When you're ready, come back, check your answer. All right, if you did this correctly, the radius was 3.7, so the surface area was about 129.03 millimeters squared. The volume was about 106.09 millimeters cubed. If you are in academic geometry, you are done. You could stop the video now. If you're honors, come on for one more problem. All right, so example 7, we're going to find the surface area and volume of this figure. So this, if you recall, we have two of the same exact shape, so it is a prism. The shape that it is has 6 sides, so it's a hexagonal prism. So we're still going to do area of the base, perimeter of the base, and height of the figure. But since the base is a polygon, we are going to have to do 1/2 NAS. So if we look at it, we know that it has 6 sides, so n is 6. We don't know what a is yet, and the length of each side is 3. So we set this up, and we have, sorry, I lost my calculator for a second. We have 30 degrees is the angle, because that's half 360 over double 6, or 360 over 12 is 30. The bottom is half the side, so that's 1.5, and we're looking for the apothem. So we're setting up tangent of 30 equals 1.5 over a. So we're going to do 1.5 divided by whatever the tangent of 30 is, and we get about 2.6. So that's what a is. So now the area of the base, or 1/2 NAS, is 1/2 times 6 times 2.6 times 3, and we get 23.4. All right, so that takes care of B. So if B is 23.4, I still need P and H. So P, 6 different sides, all of them are 3. We have 3 times 6, or 18 for P. And then the distance between the two bases, the height here, was 12. So now we're going to do our formula of surface area and volume for a prism. If you recall, surface area is 2B plus pH. So that's 2 times 23.4 plus 18 times 12. So that's going to be 46.8 plus 216. So our surface area is 262.8 meters squared. The volume is just area of base times height. So that's going to be 23.4 times 12. So my volume is 280.8 meters cubed. That is it. Congratulations, you have finished honors geometry. We covered it all.